I've had a few questions about some of the linear programming problems that are coming from chapter 7, 8, 9, and 10, I think it is. There's 4 different chapters. So here's one of the problems. It's like the 4th or 5th one, I don't remember exactly, on the homework assignment that we could look at. So one thing to remember too is the formulation part is an art as well as a science, which means you need to spend a lot of time doing it, so you're expected to be looking at other resources to be practicing these problems. The homework is a good resource because there's lots of problems on there to practice, but there are other areas too you can look at. So let's look at this problem. George Johnson recently inherited a large sum of money. He wants to use the money to set up a trust fund for his 2 children. The trust fund has 2 investment options: a bond fund and a stock fund. The projected returns over the life of the investments are 8% for the bond and 20% for the stock. Whatever portion of the inheritance George finally decides to commit to the trust fund, he wants to invest at least 40% of that amount in the bond fund. In addition, he wants to select a mix that will enable him to attain a total return of at least 5.5%. Then part A says, formulate a linear programming model that can be used to determine the percentage that should be allocated for each possible investment alternative. If required, round your answers to 3 decimal places. So they were nice enough to go ahead and tell us what the decision variables are. So they define them as let B equal the percentage of funds invested in the bond fund. S is the percentage of funds invested in the stock fund. And so we have 2 variables, that top part, right? So then down here in this table, we have coefficients go in here, numbers go in front of these boxes when you're filling it in. In here, we need a maximize or minimize function. If we're trying to make more money, it makes sense that here this is a max. And then the return on every dollar that I stick in the bond is 8%. So this should be 0.08. And for stocks it was 20%, so 0.20. It asks for 3 decimal places. Hopefully it doesn't really mess up anything. And then subject to, that's what the S period T period stands for. 3 constraints in addition to non-negativity. So 3 structural constraints. The bond fund minimum, so they go ahead and label them for us, which is pretty nice. There's a minimum return and then a percentage requirement. So the bond fund minimum, we're saying we want the what's it say up top? He wants at least 40% of the bond fund to be in 40% of what he invests in the bond fund. So what that means is on the right hand side, that needs to be 40%, because the way the decision variables are defined are percentage of funds invested. So this is a 0.400, right? And the constraint here is a greater than or equal to. Right? The coefficient on the bond, the percentage of funds invested in the bond, that's a 1. It's saying, because of the way it's defined as percentage. Right? So if B happens to be 13%, well, obviously that's not good. It doesn't meet that requirement. So if it's 50%, so if B is 0.5, then 1 times 0.5, that's bigger than 0.4. The minimum return is probably a little bit easier. We know we want a minimum return, so we want greater than or equal to, and they want at least 5.5%, so it's 0.055. And the way we make sure that we have to put the return for both the bonds and the stock in there. So this is the same thing as our objective function, actually. So this is 0.080, and then this guy is, for stocks, 20%. And then the final constraint is a percentage requirement, they call it. And here, well, all they're really trying to say is, I have to invest in either bonds or stocks, and I have to invest everything that I set aside to invest. It all has to go between those two areas. So I have to invest all of it, a 1, right, 100%. So in this case, it's going to be a strict equality, and then it's going to be whatever my percentage of bonds and whatever my percentage of stock is, right? Because again, the way the decision variables are defined, if B is 0.5 and S is 0.5, then those add up to 100%, and I'm investing everything. So that's the formulation part. Part B then goes on to talk about solving it. So we could solve it if we set it up in Excel. Remember, a variable is a column, the rows are constraints. So our objective function was for bond 0.08, 0.2 for stocks. The bond fund minimum was a 1, and we said that had to be greater than or equal to 0.55, 5.5%. The minimum, no, sorry, that's the 40%. All right. Trying to do this without going back to the Word document. The minimum return was the 5.5%, so 0.055, and that was the 0.08, and the 20% on the stocks. And then percentage requirement, we had 1s and 1s, and that was a strict equality, equal 1. And then we need left-hand sides. So to do that, we're going to do the sum product function of our output, which is up here, and our coefficients, and then drag that all the way down, and then I'm going to go ahead and put the objective function value, I'll go ahead and anchor those two. Why not? In case I just had to move it. So I like to highlight the stuff that comes out. All right. Then we're ready to set it up in Solver and solve it. So if I do data, Solver, my objective function is F2. I put it in F2. Maximizing by changing the variable cells, these two guys. Subject to the constraints, add. I have 2 greater than or equal to, so I can select those at the same time. Change it to greater than or equal to. Pick the right hand side. Click add, and then I got one more constraint, which is a strict equality, making sure I use all the, I have to go into either bonds or stocks. And then make unconstrained variables non-negative, make sure that's checked off, and then we're doing simplex LP because we're doing linear programming. Click solve, and we see that we want to put 40% into bonds, 60% into stock for a return of 15.2%. Alright, so that is able to solve that with no problem. Notice that the bond thing is the thing that's really restricting us, because we said we wanted to put at least 4% into the bond. Right. Over here somewhere, I could have kicked out a sensitivity report, but it wasn't really necessary here, so I'm not going to. Hopefully that helps you figure out some of these problems.